Hello, Calc BC. We are moving on to matrices. And so day one, we're going to learn some basics about matrices. You may already know how to add matrices and subtract matrices, but I bet you haven't been taught yet how to multiply or how to calculate a determinant. So that's going to be our focus today. Not too bad of work. Hopefully you have the note sheet and we can rock and roll. So what is a matrix? Well, a matrix is really used for kind of like a storage device, organizing a lot of numbers. It works great on that. It is awesome for computers because it kind of creates like a little mini database for you here. And a matrix is a rectangular array of real numbers. Matrices is the plural word for matrix. And we talk about rows and columns when we talk about a matrix. So what is a matrix size? It is, for instance, m by n. It has m rows, so it goes rows by columns and n columns then. So for instance, here's a good example. This one here has 1, 2, 3 rows and 1, 2, 2 columns, so it would be a 3 by 2 matrix. 3 rows, 2 columns. And when we, let's see, is there anything else? Oh, if the rows and the columns are equal, we call it a square matrix. And that kind of makes sense, doesn't it? I'm going to just pause here a minute because I got to align this board. All right, let's work on adding two matrices together. And you can get undefined. So if I'm adding, I'm looking for the same, in order to add, you have to have the same size matrix or matrices when adding. And that is because we're going to add like positions together. So this is my row 1 by column 1, and here I have row 1, column 1. So this would be location 1, 1, and this is location 1, 1. So I'm going to take location 1, 1 plus the other location 1, 1, and I'm going to add up -3 and the +1. Then I'm going to put row 1, column 2 with row 1, column 2. So I'm going to take 6 and add -4 to that one. Now I'm moving on to row 2, and I'm going to take row 2, column 1, -6, add it with -6. And row 2, column 2, row 2, column 2 makes 6 plus 6. I would bet that you've caught on to this, huh? 6 and 5, 6 plus 5, and a 5 with a -3 gives us a, what, -2, 2, -12, 12, 11, and a 2 as our final matrix, the result of adding two matrices. So we had a 3 by 2 matrix added with a 3 by 2. They have to have the same size, and notice what we get out are 3 rows by 2 columns. It would be exactly the same row column orientation. Subtracting them, well, subtracting is not much harder than addition. Once again, you want to have must have same size. Must have same size matrices when subtracting. So I'm just going to analyze this. Oh, it's a 2 by 2. That makes this a square matrix and another 2 by 2. So we're going to subtract these values. And once again, we're going to be thinking row 1, column 1 with row 1, column 1. So 0 minus -2. I'm going to go row 1, column 2 with row 1, column 2. So -3 with the -4. -3 minus -4. Moving on down a row, row 2, column 1. So I'm going to take the 2 with row 2, column 1 with the -6. 2 minus -6. and this 2 with this -1, 2 minus -1. Wow, so many negatives. And that's going to give us a +2. So turn to plus, so we're going to get a +1, goes to plus, we get an 8, goes to plus, we get a 3. When we started with a 2 by 2 times a 2 by 2, we resulted in a 2 by 2. No big surprise. Got the right answer. Okay, we got that accomplished. Let's move on to a scalar. A scalar is very easy. Notice I have a 5 out front of this whole matrix. Well, the 5 is just going to multiply into every term of this. So I'm not going to show that multiplication, just let's do the multiplication. 5 times -6 makes -30. 5 times 0 is 0. 5 times 1 is 5. 5 times -3 is -15. And then let's go 5 times the bottom row, and we'll have -25 and a +15. If I started with a 3 by 2 matrix, I'm going to finish with a 3 by 2 matrix. And there's our result. All right. Sometimes you always want to make sure that you're checking your size first, because that determines whether you can define the resultant matrix or not. And here I notice I have 3 rows by 2 columns. Remember, it's rows by columns. And on this one, I have 2 rows by 3 columns. And that is not a match. So this does not match. And so this operation then is undefined. Can't do it. Next, let's talk about a determinant and how you calculate a determinant. It depends on the size, because the procedure for finding the determinant is different based on the different size matrix. So a 2 by 2 is very simple, and here you can see the formula for calculating it. I take A times D minus C times B. So start in the upper left-hand corner, that's your first diagonal, and that will be your first product that you write down. And then you minus the other diagonal. So I kind of think of it as this, and then come back across, but you can do it however you want. We should get an answer of -10, it appears, huh? So I'm going to take, for my matrix, or for my determinant here, -1 times that -2. I'm working across this diagonal first, and then it is a subtraction sign, so subtract the other diagonal, which is 4 by 3. Which gives us a 2 minus 12, or a -10. The next one is a 3 by 3, and it's a little bit more work. What we're going to first do, you can kind of see the layout here. We are going to take and extend our matrix. We're going to add the first 2 columns all over again. Notice how those are the same. Yeah, you can really see when I draw through it, huh? How about we highlight that? All right, so this column ADG, we extend and write it again. The middle column BC, BEH, we make with BEH. And that's the startup of it. So let's do that. Let's extend our column. I'm going to have a 5, 2, -2. There's the first column repeated. Then middle column, I repeat. And I'm doing this because the procedure for determining the determinant, how'd you like that, is to multiply across these diagonals. Okay, so we're going to multiply across these diagonals. And if I can see through my numbers, I'll be in great shape. So I'm going to multiply. I'd get -10. -10 times -4 would be +40. And, a place to store it would be just down below. And then we'll add to it the next diagonal of products here. So 3 times 5 is 15, times that negative will be -30. and add with that. 4 times 2 is 8. 8 times 2 is 16, and I noticed I have a negative on that. All right, then we come back across the other direction and make another set of diagonals. Now I'm going to come across this set of diagonals. And I do exactly the same thing. It's a product. So 2 times 2 is 4, times 4 is 16. You know, I was thinking positive there. Then this and this will make positive, so I get 10. 10 times 5 is 50. And once again, we're adding. Coming across this other diagonal, it looks like it's going to turn out to be a positive as well. So I'm going to have 8 times 3 is 24. Now, would you please add those numbers together? On top, 24 and 16 make 40, 40 and 50 make 90. Maybe I'll put that in blue. The bottom sum would be a 10, I'm thinking -6. And we pull this together by going bottom number minus the top sum. So I'm going to take -6 minus 90 gives me -96. So the determinant of a matrix is actually just a number. Okay, so that's what you're trying to get to, is just this number. And yes, your calculators can do it. But I would like you to practice by hand, just so you know how to do these by hand. I'm sure there's going to be some courses in college where you are not allowed to use calculators, and I want to be sure that you understand the process of what the calculator goes through to get the determinant. So I'm on this next example, example 7, extending my 2 rows, recopy the first row, recopy the middle row. Now go into the diagonals, and we're going to multiply across the first set of diagonals, and this is going to be a 0 plus, I'd have 9 times a -5 makes -45, summed with a 4 gives me -41. Now I'll come back across the other direction, get those, the sum of those 3 products. 0 plus 25, 16 times 3 is 48, -48, sums up to -13. And now all you need to remember, how about -23? That felt wrong. -23 there. Now it's just remembering, is it top minus bottom or bottom minus top? It is the bottom number minus the top number. So -41 minus -23 gives us a -18. Yes. So that's a determinant of a 2x2 and a 3x3. I have another method to show you on a 3x3, but we'll save that probably for Monday. And finally, our last task of the day is matrix multiplication. So we're going to take two of these matrices and multiply them together. It's very important on any operation of matrix to note what your row and column size are for each of these matrices. With addition and subtraction, we must have a match between our 2 matrices. They must be the same size. That's not true for multiplication. For multiplication, you need your inside numbers to match, and you'll see why in a minute. All right, so what do you think this would be named? Is it a 2x3 or a 3x2 matrix? You're right, it's a 3x2 because we do rows times columns. 3 rows, 2 columns. This other one is a square matrix. I like those because I can't go wrong. We get a 2x2. Now, when assessing whether you can multiply 2 matrices, you're going to check the inside numbers. These inside numbers must match. Okay? If those match, you're going to be able to do the matrix multiplication. And the outside 2 numbers tell you the resulting size. of your matrix. So I now know that my resulting size is going to be a 3 by 2. And I find that to be helpful. Okay, I'm sorry, I had a phone call. Here we go. How are we going to do this? Well, matrix multiplication. It is a row times a column. Okay, and what do you do with that? Well, you take the first number 5 and you multiply it by the first number in the column, so that'd be -3. So I'm going to take 5 times -3, add that with 4 times -5. 4 times -5. And if I had a longer row and column, I would just keep doing these products and summing method, okay, till I'm done with my row column. And now you can kind of understand why we need these inside numbers, the number of what are columns here, to match up with the number of rows in this other item, because I need to have a one-to-one match, 5 with -3 and this 4 with this -5. I need, the same size so that I can get a complete match. All right, that gives me this position of 1, 1 here, okay? Now, let's see, what was our overall size? It was going to be a 3 by 2 matrix. So I know I'm going to have 3 rows and 2 columns. Here's my 2 columns, and here I'm going to extend this so I can get my 3 rows. I think sometimes it's really helpful to know what your outcome is going to be, just because it helps place your numbers and you know you're doing kind of the right steps. All right, now, because this is position, well, I'm on row 1, aren't I? And this would be column 2. This would be position 1, 2. So that means I'm going to take row, I'm going to take row 1. Let's use the highlighter. Row 1 and multiply it by column 2. Row 1, column 2 makes this position here. So row 1, it's going to be a 5 times -5. 5 times -5 added with 4 times 5. Okay, now I'm going to move down row 2, and this is column 1. So this would be row 2 times column 1. Row 2, which is this one, times column 1. And I'm going to take 1 times -3. 1 times -3 added with 2 times -5. I move over and I move down in the column. Over in the row, down in the column, and put those numbers together. All right, now I'm on row 2, column 2, so I need row 2 times column 2. And I take first position with first position, 1 times this -5, added with second item in the row, second item in the column, 2 times 5. Now we're moving down. We're in row 3. So this is row 3, column 1. All right. So row 3, column 1, 6 gets multiplied by 6 times -3 added with 2 times -5. What did I say? -2? -2 times -5. All right, the final one here. We need row 3, column 2. Row 3, column 2, multiplication. Here we go. 6, -5. Added with -2 and 5. Make sense? It's a little bit like what? Patting your head and rubbing your tummy, I always feel. So now we just do the math. So I have -15 and a -20 makes -35. I have a -25 with a +20 gives me -5. -3, -10 make -13. -5, +10 looks like +5. -18, +10, how about a -8? -30 with a -10 adds up to make -40. There is our product of the two matrices. Hopefully you took good notes on that. Otherwise, rewatch the video. I'll post it. This last one, what do we got? This is a 2x2 because it's square, isn't it? 2x2. This has 2 rows, 3 columns. So you tell me, can we do it? Yes, we can. We got a 2x2. So yes, it's doable. It matches, which is a great thing. Well, actually, if it didn't match, it'd be better because then we wouldn't have to do it. Then we have the outside measurements 2x3. That tells me the dimensions that I'm going to finish with. So I like to set up 2 rows, 3 columns. Because then I know what I need to fill in and where I'm belonging, right? I do like to, I mean, I don't usually write it, but I do like to think I'm taking row 1 times column 1. Row 1 times column 1. And it just helps keep me in my place. So I'm going to get a 6 times -6 gives me -36, added with 0. Got that? I took 6 times -6, -1 times 0, added the 2 results. Now we're moving over. We're taking row 1, column 2. Okay, there's my column 2. 6 times -1 would be -6. -1 times -4 makes +4. And I know, honestly, you guys, you could add that together as you're saying it, and feel free to if you get the hang of this now. All right, next up, row 1, row 1, column 3. Row 1, column 3, 6 times -6 gives you -36. Added with -1 times -6 gives me +6. All right, moving on down the road. So we are going to have, because this is position, here's 1, here's 2. This is row 2, column 1. Row 2, column 1. Whoa. Row 2, column 1. -3 times -6 makes 18. -3 times 0 gives me 0. Move over. Let's move over. Row, I guess they're connected. Row, geez. Row 2, column 2. -3 times -1 gives me 3. -3 times -4 makes +12. Okay, and one more. Row 2, column 3. -3 times -6 makes +18. -3 times -6 makes +18. And if you simplify, we should result in this matrix. Hopefully all those numbers come through. Quick double check. It is fact that that works. All right. So you now learned multiplication. You have a worksheet for an assignment and a little bit of addition, subtraction, scalar. Scalars are easy. You might have seen those on your ACT exam. And then you get into multiplication. Be sure you check the size of the matrix to make sure you can do it. And then you've got some determinant work. Is there a 3x3? Yep, you've got a 3x3, so you're going to extend those rows, you know, like we talked about. And then do the diagonals. All right, party on. See you guys tomorrow.